Hello everyone. Today, we will go through tutorial 2 of Aspen HYSYS with these objectives. As we have this example of distillation column, here is the steps to simulate it. First, start a new case. Select benzene and toluene for the components, which they can be found either by searching by their names or their chemical formula. Next, use the Peng-Robinson fluid package, where Aspen HYSYS will always let you know if the fluid package is appropriate or not. Since this is a simple distillation case, 3 process streams are needed. Place 3 material streams for the feed, the distillate, and the bottoms. Also place 2 energy streams for the reboiler and condenser. Next, rename the material streams to feed, distillate, and bottoms. Also rename the energy streams to condenser energy and reboiler energy. Now a distillation column should be placed. From the model palette, search for distillation column, then place it on the simulation window. Now the column is ready to be hooked up to the process and energy streams. To do this, double-click on the distillation column. Hook up the streams to their appropriate locations. The type of condenser must be specified. Select a total condenser and click Next button to proceed. Choose once through regular HYSYS reboiler for reboiler configuration and click Next button to proceed. The next step is to specify the pressures of distillation column. In this example, it is assumed that pressure drop is negligible. Hence, the column is run at 101.3 kPa and click Next button to proceed. In the next step, HYSYS prompts for temperature estimates for the top stage, condenser, and reboiler. And since these are optional fields, they can be ignored, and HYSYS will calculate them when the simulation is run. The last step to fully configure the column is to specify the reflux ratio and distillate flow rate. A reflux ratio of 3 and a distillate flow rate of 2700 kmol per hour have been specified. Click Done button to complete the distillation column connection and specifications. To complete and run the simulation, verify that the feed stream are specified. For this example, an inlet temperature of 30 Celsius, a pressure of 101.3 kPa, a flow rate of 1 kmol per sec, and a feed with 70 mass % benzene have been specified. To achieve the ultra-pure distillate stream required, it has been estimated the column needs 23 trays with the feed entering at tray 7. To get HYSYS to start actively running the simulation and solving for unknown properties, the solver must be active. To activate the solver, simply click on the green light in the upper toolbar. Double-click on the column to bring up its main window. Click on the Run button to simulate the distillation process. Close the window, and you will see the distillate and bottom streams have turned from turquoise to dark blue, signifying that HYSYS has successfully solved for those streams with unknown properties, and the simulation is successful. HYSYS has the ability to use different criteria other than the reflux ratio and distillate flow rate to simulate the column. For example, the bottom's flow rate or the composition of the distillate at any given tray can be specified, and HYSYS can simulate the column based on those new specifications. To change the specification criteria of the distillation column, double-click on the column and bring up the main window. Then click on Specs to bring up the advanced specification window. Notice that there are 4 column specifications present: reflux ratio, distillate rate, reflux rate, and bottoms production rate. First 2 are active and last 2 are not. When a specification is active, that means HYSYS is using it to simulate the distillation. Next, change the specification of bottom's flow rate to 700 kmol per hour. In order to avoid over-specifying the distillation column, the distillate flow rate must be inactive. Do this by selecting distillate rate and uncheck active to make it inactive. And select the bottom production rate and check active to activate it. That is all for today. I hope you like it. And see you in the next video. Peace.